All right, good morning. Today we're working page 13 out of the workbook. And we're learning about algebraic expressions. And expressions are different from equations. Equations have to have an equal sign on them. The expressions that we'll use today will not have an expression, will not have an equation, an equal sign, but it will have the other elements of equations, which are numbers, variables, and some kind of an operation, either addition, subtraction, multiplication, or division. We can write an algebraic expression just with the numbers, variables, and operators, but we can also pronounce it in English. And so today we're going to do some practice going back and forth between just using the numbers and symbols and using the word. Okay, so at the first, it wants you to write the algebraic expression for the word expression. So n minus 8, it's going to look just like this. And let me point out that n minus 8 is different than 8 minus n. 8 minus n would look like this. Okay, here we have y plus 12. 7 times x. And there are several ways that we can write this. The first way that we're taught to write times with the big old X. So if we write it that way, it would look like this. And that's hard to tell which is the multiplication sign and which is the variable. So when we're doing algebra, we rarely write this symbol for multiplication. I'm not going to do it. The most common way, well, there's two really common ways that we show multiplication in algebra. One way is with parentheses. So if you see something in parentheses right next to something else outside of parentheses, it means multiply. If one of the things is a variable, we can write it the same thing without the parentheses, and it would look just like this. So here is a 7 and a variable right next to each other. That means multiply. We just leave out the multiplication sign. We only do that for multiplication. We don't leave out the sign when we're doing addition, subtraction, or division. Oh, here's division right here. A couple of ways to write division. First way that we learn how to do this is like this. And it's not, but when we're doing algebra, it gets really hard. This thing gets cumbersome. It's just, it gets in the way. It's hard to make it fit in with the rest of the expression. So we have another symbol that means division, and it's used more commonly in algebra, and it looks like this. This symbol right here. When I write it this way, it looks kind of like a fraction, and it is a fraction. So that's what a fraction is. A fraction is when you have one number divided by another number. So this is the symbol that I usually use for division when we're doing algebra. Okay, W subtract 4. R added to 19. So we're going to be really picky with this one. The way that this is stated, it kind of sounds like we already have 19, and then we're going to add some more to it. So we're going to write it that way, starting with 19, and then we're going to add R to it. hopefully you've all done enough math that you know darn well that 19 plus r is going to give me the same result as r plus 19. Because when we add, the order doesn't matter. But if we want to make the expression in symbols look just like the words, we'll leave it just like that. Now, this part of the worksheet is specifically designed to make you wish that you could just use symbols all the time and not have to write the words. Because here we're going to make you write it out. And I'm not going to make you spell out the numbers. But this one right here with a number and a letter right next to it is going to be 5 times x. Lots of words that we can use to describe this one. We could say 7 subtract n. You could say 7 minus n. Or you could say n less than 7. My favorite way is 7 subtract n. And I don't think there's any way to misinterpret this. Okay, that one's division. A's on the top. If we were to, oh, there's another way to write division. I almost forgot because I never do it anymore. We could write this as, this is another symbol way to do it. A divided by 5. So the thing on top is what goes inside the house when you're doing division. Um, 4 plus n, or you could say n added to 4. Let's see what letter that is. That looks like an S. Oops, it's not divide. Right, so what else is here? Okay, good. We have a good class today. Yay. And then we get to parentheses. And we can look at something like this. That has, it's more than one operation. Here's the addition, but then there's also a multiplication here. This means 2 times this variable x. So, and then some expressions also have parentheses. So this example right here, when a number is outside parentheses, it means that this number has to be multiplied by everything inside the parentheses. So I'd have to multiply 3 times y, and I also have to multiply 3 times 7. And we are going to practice this skill today. Okay, let's see. Let's just look at, this is going to help remind you of what to do as we go through here. This means 4 times x and then subtract 9. For something, oh, look, here's 4 times x minus 9. This is the one that matches up. Now this one here has a lot of the same stuff in it. It has the 4 times, and it has the x minus 9. So it has a lot of the same words in it, but it also has this thing in it, the quantity. And that's, a quantity is an amount. When you see this in some kind of a word expression, it should be a clue to you that you're going to see something in parentheses. And the stuff that's going to be in parentheses is what follows this word quantity. So we're looking for something that has a 4, a multiply, parentheses with x minus 9 in parentheses. Look down here. There's the x minus 9 in parentheses. There's the multiply by 4. So this one here actually matches up with 18. Looking at this list, I see a couple other things that have numbers in parentheses. And so you should be looking for the word the quantity to match up with these ones in parentheses. I'm going to let you work for a couple minutes.
Got it.
Good. Maximo, have you already worked this worksheet?
Yes.
Do you need
Yes.
answers?
Please.
Okay, I'll send those right now.
Thank you.
Oh, I don't think I had to do.
And I've been working on my pretest, the other one.
Oh, good. Good.
I'm halfway.
Halfway? Okay, that's good. You're probably spending too much time on it if you're only halfway done. Okay.
Wow, that one took me almost like 2 hours.
Really? Ooh, I didn't think.
Yeah, just we have. I mean, I have problems with Simplify, but this morning I worked with my tutor, and she went through too. so,
Oh,
so
good.
she helped me too.
Okay.
So
Okay. So you have.
I think I got it. I think I got it.
Um, right. So, I'm gonna I'm ready to talk about these. Tyler, are you still puzzling? Okay, so Tyler, you're muted right now. There you go. Okay. Are you still puzzling?
No, I moved on to the next page, sorry.
Oh, okay, that's fine. So I guess here, I'll just give people answers quickly and you can check your answers to this part while we're right here. I'm just going to fill them in and make sure, actually, I did these pretty quickly. I hope these are the same answers that I'm sending to everybody else. Oh, I see that. Let me give it to you here. Okay, there they are.
Awesome, awesome.
Did I get most of them right?
Yep.
Okay, good. Are you done checking, Tyler?
Yeah.
Okay. Right. So on the GED test, I am positive that you need to have the skill to be able to take words and turn it into an expression. And it may have you do it just, you know, kind of like this, or it may have some kind of a word problem that you need to be able to write a whole equation in order to solve it. And so an expression is, every equation is made up of one or more expressions. So if you're good at this, you can get good at writing equations also. All right, so the next thing that I would like to do is actually an activity. So it's in your notebook, and it is looks like this: distributive property using area. Oh. I just spilled a bunch of water, so I'm going to clean it up. Oh, it's good to have a little drama to go along with. Wishing that it had all landed in my lap instead, because that would have felt good. Was the rest of it. Oh, that's ice. Okay. Okay, yay. I'm glad that was water and not like a latte with a bunch of whipped cream or sticky stuff or something.
Sounds good.
There we go. Okay, now this page is kind of wet, so you know I'm going to have problems when I try to write on it. So this particular page, and hi, Billy. This comes out of your notebook back in the activities section. So back behind that purple page, you should be able to find this one. And so the distributive property that was taught in a lesson in section, I think that was section 1. Personally, I don't care if you know the name of it, but you do have to know how to use it. It'll be very important on for many of the problems that you need to solve on the GED test. So the first part of this is going to feel a little bit like geometry. If you happen to remember what the formula for the area of a rectangle is, the formula for area of a rectangle is just the length times the width. And what we get out of this formula is the number of little squares that would fit inside there. This rectangle here since it's a width of 4, I could show it as 4 rows, and it has a length of 5, so I need to show it as 5 columns.
20.
And when we do that, then we could go through and we could just count the number of little squares that are in there. It's 20. And you don't want to have to count it each time. You just multiply it 4 by 5. This rectangle doesn't give us a number for M. It's some kind of a variable, but we can still express the area of it by writing 7 times M, just like that. This one is going to be 3 times A. And notice in both times, I wrote the number before the variable. That's just kind of standard way of doing it. Most mathematicians write the number first and then the variable. But what do we write for this one?
X2. Oh. Square. X squared.
Okay, all right, I like that. So you're saying X squared. And another way to write this, it's just as good, is just to say X times X. This is definitely a shortcut. It just looks less
You
complicated.
can use it. You can use it. As a square or you can. I mean, you can use it both ways.
Yes, you can.
Okay. Okay.
Okay, now this time there's two rectangles or two boxes. This first one is going to be 4 times X. But what's this one?
Or 3 times 4. So
4
that'd be-
times 3. Yeah. And how do you know it's 4 times 3?
it's going to be the
This is
same.
Because it's the same height as that one. So it's 4 times 3. And we can do the same trick with this one. First one is 7 times A. But this one is going to be 7 times 9. If you need to use the calculator to do 7 times 9, it's okay with me. And then this one, X times X, let's use that one, X squared. And then this box is going to be X times 2. And the traditional way of writing it is with the number first. So 2X. All right, so starting with this next part, this is a different idea. This time we have this length here. And I know that this part of it is a length of 9. This part of it is a length of X. And I don't know how long X is, but I know if I wanted to consider the whole length of the whole piece, I'd have to add this length to that length. So plus 9. So all I can do is write an expression to show what this is. Okay, this piece here, we have an X and a 4. They add up to X plus 4. And the last one is going to be A plus 2. In each case here, I wrote the variable first, only because it was on the left-hand side of the picture. Okay, now we're going to combine the ideas here with these ideas. This time we have 2 rectangles. We know the dimensions of one of them. Well, we know what the dimensions of this one is too, because this length is the same as that. So inside here, I could write that this rectangle here is 5x. And this rectangle here is 5 times 7, which is 35. And now if I said, okay, I don't want to know the size of the little one and then the size of the big one. I want to know the size of the whole thing all together. So to get that, you could just add these 2 pieces together. You could add 5x plus 35. And when we add 2 things together, the answer is called a sum, a word that means answer to an addition problem. So here we can express the area of this big box as a sum, 5x plus 35. Here's another way that we could look at it. Up here, this total length was x plus 9. We can do the same thing here. And we can say that the total length of this box is x plus 7. If I think of it that way, then the area of the is going to be 5 times x plus 7 right here.
Why is it not mine?
I have a question.
Okay, now I got 2 questions. Billy, what's yours?
How did you get 35? 7 times 5, right?
Yes, 7 times 5.
Did you multiply that across like that then?
I multiplied it because, going back to this picture right here, if we just have one little rectangle here, the area of it is going to be 4 times 5. Because there's 4 rows and 5 columns, and that makes altogether 20 little squares inside of it.
And the area of the rectangle is always length times width.
Area
Okay.
of a rectangle
I
is
got you.
always length times width. Right, so let's just do another one. And first, let's just write what the area of each rectangle is. X by x, going to be x squared. X by 12 will be 12x. So if we want to write the entire area as a sum, we can just add those 2 pieces together. X squared plus 12x. If we want to write it as the product of the width times the length, then we need to add up the x plus 12 and multiply that by 9. So it's going to be x times x plus 12. Now what's important here is this is one picture, it's one side. There's 2 different ways to show its size. These 2 things are equal. If I knew the value of x, I could put that number in here and here, and I could do this stuff and I'd get a number. Or I could put the value here and do all this stuff. And I get exactly the same number that I did this way. Have to. It's one picture. This last one, a times a is a squared. A times 8 is going to be 8a. As a sum, we add the 2 boxes together.
E plus A.
As a product, we're going to multiply the sides. So I'm going to multiply A times, and then the whole length of this side is A plus 8. Okay, so, oh, hi, Lynn. I think you missed the drama of when I spilled my water all over my desk and book and computer and worksheet. But we got things dried out now. And Lynn, this worksheet is in the activities section of your workbook. It's behind that purple page. Okay, so when we get down here, this is asking you to try to do it without the pictures. And I'll show you how to do that. But first I want to convince you that I could draw this picture. So this picture would look like this, where we have the height is 4, and then the width of it is going to be x plus 7. So the whole width here would be x added, or 7 added to x. So if I was going to figure out the other way to write it, which is going to be as a sum, to figure out what I'm adding together. Well, I'm going to add together the 4 times x. And then what I add with that is the 4 times 7. So with this one, if you wanted to do it without the picture, which I hope you get to today, when you see something in parentheses added up, and then there's a number outside, right next to the parentheses, you know you're going to have to multiply this 4 by each in the parentheses. So it's going to be 4 times x plus 4 times 7. So let's do number 15. 7 times x, 7. This time we're going to subtract. 7 times 3 is 21. Okay, I'm going to give everybody a couple minutes to try to work some of these other ones. I'll be right back. I'm going to fill my glass again. Oh, and of course, they give us negative numbers, right? Oh. But you can use your calculator with these. It's sort of. You can't put x into the calculator. So you have to know how to do negative 2 times x. Well, that's just negative 2x. And then we're going to add. Now you have to multiply negative 2 times 4. And you may use the calculator for that. Negative 2 times 4 comes out to be negative 8. Is anybody ready to check answers?
I do.
Oh,
Yes.
okay.
To the second page, please. Thank you.
For the second page,
Yes.
on this side too?
Yeah, the other. Yes.
Oh my gosh, I'm really impressed. Okay, I said I was going to let you check answers. I don't know if I have answers for this. Let me look and see if I do. Wait. I could. What does it have to do with this? No, I don't have an answer sheet for that. So, sorry, we're just going to have to check answers the old-fashioned way. Let's see.
Number 19. I just want to see if I got that one right. 3M.
Yeah. Let me. I'm just looking to see if I happen to have an answer key that I can. No, I don't. Okay, so we're going to check answers the old-fashioned way, which means I'm going to sit here and work them for you. Oh yeah, 19. Okay, so 19 is different than the other ones. Let me go ahead and fill these in quickly so people can check their own answers. Oh, and I would appreciate it, Joe, if you would look and see if I'm getting the same answers that you did. This one right here, most people do not like seeing a plus and a minus right next to each other. Never see that as a choice on a multiple choice answer on the GED test. Add a negative is the same as subtracting a positive. So there's another way to write this. And that just looks a little cleaner. Okay, number 19. So 3 times m times m is going to be 3m squared. And then we're going to add 3m times 2 is going to be 6m. That what you up?
Yeah.
Okay. And this one is squared minus and a times 12 is 12.
Yep.
I don't like these, but I get it. But they suck.
Okay, so you don't have to like them. I do not require that you like anything about math. And in fact, this is true. Some of the very best students that I've ever had are the ones that really hate math because they just want to get through it and they work really hard just to get it over with. And so that works for me too. Okay.
Practice, is that going to be on the GED a lot? That right there, I'm guessing.
There will be this skill.
Probably like 20 questions.
Well, it's not going to have 20 questions like this all in a row. Okay, they won't look like this. There might be some kind of a word problem where you have to write the equation to solve it. And the equation that you write might have something like this in it. And so in order to solve it, you're going to have to know how to do this. So yes, this is an important skill. It's not the only important skill. Okay, so what we've done so far is just this thing called the distributive property, and it's where we're distributing or passing out this multiplication. So we passed out multiplication to the x, and we passed it out to the 7. Let's look at the other side now. So now this one is called factoring. But so far it looks kind of like the same thing, doesn't it? Factoring and the distributive property are inverse operations. So they're opposites. Kind of like multiplication is the opposite of division, addition the opposite of subtraction. So it makes perfect sense for us to do this right away because we're going to be using the exact same skills and a couple more skills. This is different actually, this is the same as what we did before. You just fill this in. 2 times x, 2 times 6, and then there's 2 ways to write it. 2 times the x plus 6, or 2x plus the 12. Now this one's a little bit different because it gives us the answer problem. It gives us one of the factors, or one of the numbers that we would have to multiply to get this answer, but the other factor is missing. Let's figure out, well, what times 5 equals 5x?
4.
Well, no, but if I said what times 5 equals 20, the correct answer is 4, and the 4 goes over there, because 4 times 5 is 20. What times 5 equals 5x must be x. Right. Now there's 2 ways we can write this. We can write it as 5 times x plus 4. Or we can write it as 5x plus 20. Oh no, both factors are missing here. So with this one, I know that one of the factors will be 6 and one of the factors will be x. Should I put the 6 here or should I put the 6 here?
Right there.
You think it's here, all right. And I don't know why you chose that, but I'm gonna put it here. That means that the x would have to be, okay. And let's see if it works. 6 times x is 6x. 6 times 8 is 48. Maximo, hopefully you chose to put the 6 here because you knew you were gonna need it for this part of the picture.
Yes.
Okay, good. So again, we can write this 2 ways. 6 times x plus the quantity, x plus 8. Or we could write it as 6x plus 48. Okay, so I'm going to intentionally do this one wrong. Oh no, I can't intentionally do it wrong. It doesn't leave me any choices. Okay, the missing factor here has to be
10.
That's the only way we can get 10x. And then here, to figure out this factor, we could go, what number times 10 equals 30? Oh, I don't know. So I could do 30 divided by 10 to give me the other factor of . Oh my gosh. Okay, now this one's different because, oh no, what are they doing? They gave us this part and we have to fill in this part. So when I look at it this way, 5x plus 35, I know the 5x goes here and the 35 goes here. And it's telling me that this equals 5 times some stuff. This 5 is going to have to go over here.
Next.
And then we just have to figure out what goes here. So it's going to have to be, yep, the x is the missing factor here. And over here to find this missing factor, it'll be
35 divided by 5.
by 5. Here we go. And now it's easy to fill in this part. A little puzzle. Okay, I'm gonna let everybody work on the next few. And I'll just tell you this right off the bat. There's a couple of these that are just as easy as the one I did here. And there's a couple of them that'll take a little bit more thought. Puzzle over them. I'm going to go ahead and work these as you're working. I hope that you're ahead of me, but if you get stuck, maybe you'll be able to see what to do. Oh. Okay, this might be mysterious for number 7. It's 3x subtract 21. The 3x goes here. What goes here is going to be 21, but you have to keep the sign with it. So this is going to be negative 21. Oh, and it didn't give me, oh no. So here's one where this part of it would work out perfectly if I put the 3 here and the x here. And it would also work out perfectly if I put the 3 here and the x here. So I have to think. And I'm going to do this first. I'm going to do it wrong so that you can see what goes wrong. If I put the x here and the 3 here, this part's fine. But now when I get to this, I'm going to have to take negative 21 divided by x to figure out what this factor is. And I can't do that. So
It's to be the other way.
it's got to be the other way.
Mhm.
Okay, this still
So
works.
20
Now, negative
divided by
21 divided by 3 comes out to be
7.
negative 7.
Negative 7. Negative 7.
Yeah. Okay. So now what does this look like? This is the thing that goes on the outside. And this goes on the inside. And it can just be x minus 7. Interesting. And I'll just point this out because it seems mysterious. Here we're calling it subtract. X subtract 7 or x minus 7. Here, the same symbol, we're calling it negative. And yes, that's it. Subtract and negative are just so closely related that there they are. We can use the same symbol for them. And Joe, are you getting these? You already asked me for the answers, right?
I haven't, but I'm stuck on the ones right below you, just like
Oh yeah, when it just says factor. You haven't even really defined what it means. And so I'm checking these and
Yeah.
getting the same answers that I am. This is really going to be a weird one. So I think what I want to do here, and then
5x minus 9. And then I'm gonna just throw this one out there for like 11. I did 4 parentheses x minus 4.
Okay. So, and this is correct. And you could check to make sure it's correct by just working backwards now. So this would be 4 times x, subtract 4 times 4. And then, oh, yep, that's what I started with. So I know it's correct. When we're working these, Joe and all the students, I look at this and I think, I'm going to look at the number part of this and the number part of this along with its sign. And I'm thinking, can I think of some number that divides evenly into -7, and it also divides evenly into -35? And -7 works. That's the number that I'm going to put on the outside. When you missed the first week of class. The first week of class, we talked about factors, and a factor is a number that you multiply by. When you're told to factor something, or when you're doing a worksheet on factoring, you're looking for what number you can multiply by. And we're looking for the biggest number that we can multiply. That we're looking for the biggest number that both of these things can divide evenly into or by. We're looking for the biggest number that both of these can be divided by so that we can use it as a factor.
Cool.
That would be -7, and then it's going to be x plus 5. Yep.
No.
So factors of 9 and 81, the biggest number that it'll divide evenly into 9 and into 81 is 9. Every case, the biggest number that would divide into these was leading coefficient here. Number 14 is different.
Yeah, it's gonna be x plus 4.5. That's one there.
And what goes on the outside? 4. Okay. Let's see if that works. So 4 times x is 4x. I'm going to add. 4 times 4.5 is 18. Yeah, that works. However, and this is good news, Joe, this is wrong, okay? And here's why it's wrong, and it's good news. When we ask you to factor something, so this is a factor and this is a factor. When we ask you to factor something, we're only asking for whole numbers. We never want one of the factors to come out to be a decimal or a fraction. So I think it's good news. It makes the whole thing simpler. What's the biggest number that divides evenly into 4 and it also divides evenly into 18?
$36.
Oh no, that's way too big.
Way too big.
Let's just list all the factors of 4. Back to the first week. The factors of 4. So all the whole numbers that multiplied together will equal 4. Well, 1 times 4 and 2 times 2. Okay. So if I list all the factors of 4, they're 1, 2, and 4. I'm going to list all the factors of 18. There's always 1, 18. The next bigger number is 2. Would be 18 times 2 is 9. Does 3 divide evenly into 18? Yep. 3 times 6. Does 4 divide evenly into 18?
No. Oh, 2 is going to be.
No. 6? Oh, yeah, 6, but it's already on the list. So we're done. So if we look at the biggest common factor, it comes out to be just 2. So it makes this whole thing a little bit easier. So we're going to factor out the 2. If you take 4x divided by 2, you have 2x. Times 2 is 4. And then 18 divided by 2 is 9. So that's a lot nicer answer. We don't like answers with decimals or fractions in it. And the reason why we just absolutely have to have this rule that when we tell you to factor, it has to be whole numbers. Let you pick. If we didn't make you stick to whole numbers, there's an infinite number of correct answers to something like this. Because what you wrote down originally here is true, that these two things are equal. You could pick all kinds of things. You could pick 36 if you wanted to. But now we have to take 4 divided by 36 to figure out what that is. That's going to come out to be 1/9, I believe. Yeah, that's 1/9. So this also equals that. But man, nope, no one likes that for an answer. I don't think anybody does. All right, so it's really hard for me to tell how much of this is sinking in. There's 2 more pages of this, which it just gets a little bit more challenging as you go on here. And I would like to, I put these in here just for people that could do all the other ones easily. They can practice on these also. If you can do all of these kind, that's good enough to pass the GED test. Kind, I'll just give you a little extra practice and a little extra boost, because some of them are a little more complicated than what you'd see on the GED. So personally, I'm ready to put those aside, but I would like to know if anyone has any lingering questions on any of this. Then, what I would like to do now is just show you a couple of things out of your KET lesson for today. So let me bring up KET. Oh no. I don't know what this. Okay, this is what I want to do.
before you guys skedaddle, do you just want me to take the windows, just clean them off?
Yeah, you just open them. You'll have to open them from inside.
Yeah.
Take the broom and get them the top and bottom all around.
All right, so let's see. Make this bigger. Why did it do that? Invalid. Oh, I don't know. I've been having lots of problems today. There we go. All right, math. And then if you have not already done the pretest for algebraic reasoning, which I'm pointing to right now, that's what you need to do first before it will let you into these lessons that we're working on now. So I just, Joe, you told me it took you 2 hours to do this? Is that?
Yeah, a lot of it, like I said, I mean, it's been about 10 years since school, so it was definitely a recall.
Okay, so I'm assuming that when you came up with a question that you didn't know how to work it, you sat there and you tried to figure it out.
Yeah, instead of just skipping it, yeah.
And that's fine, because if you do figure it out, then that means you've got it and you don't need a lesson on it anyway. The other approach would be, if you don't know how to work something, you just skip that question and go on to the ones that you know, and then it assigns you lessons on that topic. So one way or another, you're going to have to figure it out, and you can get through the test quickly if you only answer the things that you know, or you can take more time on the test and end up spending less time in lessons. Either method works with me, but you have to get through the test before it lets you have the lessons. So, unless you're the teacher. If you're the teacher, you don't have to go through the lessons. You can just bring up somebody else's study plan. And I want to look at, I'm going to pick Lucy because I know she is not using hers today. Okay, so the algebraic reasoning study plan, the first lesson is on signed numbers. We did some problems yesterday on positive and negative numbers. The second lesson is this basic properties and operations. I'm going to let you guys go through this and take time with it. There's some videos that go along with it. Some of them are okay. They're probably better than the recordings I make. Okay, so one of the properties that happens with numbers, and you're probably already familiar with this, but you may not remember the name of it, called the commutative property. If you commute to work, it means you change where you are. And the commutative property just says that you add things up forward or backwards, and you're going to get the same answer. Also, when you multiply, the order that you multiply two numbers together, it doesn't make any difference. It's going to give you the same answer. Commutative property does not work with division, and it does not work with subtraction. Well, that's an easy one. And then we have this thing called associative property, and that's where if you have 3 numbers, you could take the first 2 and add them together, enter on your calculator, and then add a third number. Or if you wanted to, you could add the second and third number together and hit enter, and then add in the first number. And that's okay. you're going to get the same answer. And you can do the same thing with multiplication. So you can change the grouping as long as you're just adding or just multiplying. Doesn't work for subtraction, and it doesn't work for division. And it also doesn't work when you're mixing addition and multiplication. And then there's this one, the distributive property. And that's the one that we worked on extensively today. You have something in parentheses, either added up or subtracted. And you have one number on the outside that you're multiplying the whole thing to. So as you're working this, if you're assigned this lesson, and if you're working it, then I would say pay special attention to this distributive property. And there's lots of practice questions that go along with it. Come up somewhere. Here we go. So what should the expressions? Oh my gosh. What do they want there? So 3 times 12 minus 3 times 7. Oh, okay. So here's subtraction. But both of these terms have times 3 in it. So we can factor out the 3, or in other words, we can put the 3 outside the parentheses and multiply it by, we're still going to have the 12, we're going to have the 7, and it's going to be a subtraction. So I think it looks like that one. 3. And then if you're not sure, you can just check, you can do the arithmetic on this, because since it gave us numbers, we really can do this. 3 times 12 is 36. 3 times 7 is 21. 36 minus 21 comes out to be 15. Let's see if this comes out to be 15. Oh, I see a problem here. Oh, I know what I did. No, I don't know what I did.
Well, if I wrote it out with yeah,
this is right.
B's.
Yeah.
3's would be A's, 12 would be B, and 7 would be C. So would it be C? 8 is 3 squared.
We'll check that one, okay? But let's finish checking this one. If I can just subtract this because it is just 2 numbers. 12 minus 7 is 5. 3 times 5 is 15. That is the same number that I got when I did this one. Let's see what happens if we try this one, your choice C. So 12 minus 7 is 5. But 3 squared is 3 times 3, so that would be 9. And 9 times 5 is 45. So we really have changed the value of it by putting that squared there. So I would encourage you, Joe, just to look at those worksheets that we did a little bit and see if you can really conceptualize what the difference is. It'll put you on a whole nother level of math thinking if you can just truly figure out for yourself what the difference is there. Let's see what else is in this skill check here. Okay, word problem. 12 sweatshirts at $23 and 28 t-shirts at $14. So which expression represents total sales? If I just wanted the total sales off the sweatshirts, I personally would multiply 12 times 23. I certainly would not add up 23 plus 23 plus 23 plus 23 plus 23 and do that 12 times. I would just multiply. And then 28 t-shirts at 14, I'm going to need a 28 times 14. And then I would have to add together the money from the sweatshirts and the money from the t-shirts. So which one of those looks like it has multiplication and addition? And it looks like it would kind of give us what we want. Yeah.
D.
Hey, Joe likes D. Does anybody else vote for D? You like that one too, Maximo?
Yes. Yes.
Yeah. And
Yes. Yeah.
yeah, we already know that, you know, word problems and stuff. It's
Yeah. Because Tolstoy 23.
challenge just to read that. And hopefully what I always wish for my students, whether English is their second language or not, I always wish for them that eventually it becomes easier to think in math than it is to think in English.
Let me see.
That's okay. And then here's some more stuff. Oh, okay. So this has a whole lesson on exponents, which is cool. We did a little bit on exponents earlier on. So Joe, you missed that lesson too. We didn't get into as much detail as what they're doing here. This is great stuff. And there will definitely be questions on exponents too. So, okay, so I am going to stop. Oh, I've got your pictures over where I need to log out here. Here we go. Stop. And, okay, so top priority is to finish the pre-tests. And then, yeah, you finish the pre-tests. The assignment is section 1.1 and 1.2 in algebraic reasoning. And
So
I think I'm giving you a lot of work. I think that's a lot. You know, another hour at least. Teachers love giving homework. No, I don't love giving homework. But I don't know how else. Usually when I teach class, we have class in a classroom for 2.5 hours. And so we have the lesson and then everybody has an hour to work on stuff. So this, hopefully you can get most of the homework done in an hour, so it comes out to be the same amount of time. And if you have questions, take a picture, shoot it to me on a text. I'll have my phone with me most of the day today. Glad to help you out.
Awesome. Alrighty.
Anything else from you today? Nope, you good? Maximo?
Thank you.
Okay,
Thank you so much.
you're welcome. I'm gonna stop recording.